Morning, kiddos. Today we're going to identify each component of a window unit. Window unit falls under EPA 608 Type 1 appliance. So when you get your Type 1 certification, this and other small appliances like refrigerators are under Type 1, EPA 608 Type 1. So the first thing we're going to do is we're going to identify each component of a window unit. And it's not much different for the other appliances like the refrigerator. They all have these same components. So we need to specifically identify these so when you're taking the core, you will be able to understand what they're talking about. Let's start with the main component of a window unit. The main component of a window unit is the compressor. All right, it has a discharge line and it has an intake line, which in the trade we call this the suction line because the refrigerant is going into the compressor, and this is the discharge line, so it's coming out of the compressor. All right. One of the things we need to know that we never have liquid going into the compressor or coming out of the compressor. It is actually that it can damage the compressor if you ever get liquid refrigerant in here. All right. So this is the compressor. On the unit, the small coil right here, this part right here, let me turn it around. This part right here is the part that goes inside the house. This is the evaporator. This is the net. This is the net that catches the heat. A good example of it is just like a net when you're catching fish. You throw a net in the water and you pull it and you grab fish, and then you bring it up. Does the water stay in the net? No, the water just goes back into the lake or ocean, and the fish stays in the net. The fish is an example of heat. Heat and air. Heat is a separate element from air, so we can separate the heat from the air. So that's why when you pull the air through your closet, through your filter in your house, it goes in warm and it comes out cold, is because it's the same air. It's just we remove some of the heat. Okay, so this is the net. This is what catches the heat. All right, this is what absorbs the heat through conduction. All right. On the back side, this is the part on the outside of the house. All right. This is the condenser. This is like a radiator on the car. It ejects the heat that you've taken in. You take heat in here and you inject heat out here. So when you walk by it, when you feel it, it feels hot. That is actually the heat, not the air. We only caught the heat. The air is still in the house. We caught the heat from inside the house, and now we're putting it outside. That's why you feel it. That's why it's hot when you go by it. All right. So we're ejecting the heat. So the condenser ejects heat. The evaporator absorbs heat. That's the best definition of each one of those components. So the evaporator absorbs heat. The condenser ejects heat. Example, a radiator on a car. This is like a fish. This is a net, and we throw it in the water and we catch fish. In this case, where we got the evaporator, which is the net, and we catch heat, and the air just keeps going and goes back into the house. All right? We're only catching the heat with the evaporators. Also, on a window unit, because they don't provide a service valve, they have to provide what they call an aperture, which is basically a process tube. Process stub. This is the process stub. I painted it white so you can see it, but it's basically just copper, and it's usually straight, but it's been bit and whatever. But if you notice right here, there's a little pinch in it. That's where the factory charged the system and then pinched it off to keep the refrigerant from leaking, and then they brazed the end of it. So they brazed the tip of it so it wouldn't leak the refrigerant out. But this is the processing tube. This is where you would put your temporary access ports in so you can check the charge or add more refrigerant or remove the refrigerant from the system. This is normally where you would put it. Okay. All right. Now, if you notice how I got some different colors reds and different color blues over here, this is to identify the differences between the low side and the high side. You can take a line and draw a line through here, and that would separate the high side, the low side, and the high side. The blue represents the low side. The red represents the high side. Now, the different colors of red and the different colors of blue talks about the different stages of the refrigerant, liquid or vapor. For instance, the dark blue is liquid refrigerant, and this light blue, sky blue, it represents the refrigerant turning into a vapor. Same way here. When it comes out of the discharge line, it's a vapor. And then by the time it comes out of the evaporator, the condenser, it's liquid. All right? So we're going to go through it. We're going to start from the compressor. From the evaporator. All right. Here's a metering device. It's not always looks like this. This is the metering device. This little small, tiny little tube that wraps and goes into here. This is the metering device. This is like a nozzle on a water hose. You got a full-blown water behind the nozzle, but when you pull the trigger, it sprays out water. Actually, you're not getting all the water. You're getting the water in a pressure form, but you're actually getting less water out, and it's spraying a mist. So when you put on mist setting on a water hose on the nozzle, when you pull the trigger, that's basically what's happening inside here. Okay? So this is the metering device, which takes high pressure and reduces it to low pressure. When you reduce pressure, you reduce the temperature. Remember that. So it takes high pressure and reduces it to low pressure. When you do that, you reduce the temperature. So when pressure goes down, the temperature goes down. Got it? So when pressure goes down, the temperature goes down. So that's why we're taking high pressure coming in, and we're reducing it to low pressure, which we're creating a low temperature. So that's why this is the low side. So we got low pressure liquid being sprayed in to the evaporator, and then as the liquid refrigerant, the sprayed in refrigerant circulates through the coil inside here, it's absorbing heat. And as it absorbs heat, it vaporizes. As it vaporizes, it becomes a vapor. And by the time it comes out of the coil, it's vapor. Nothing but vapor. Low pressure, low temperature vapor. It goes in as a low pressure, low temperature liquid, spraying in as a low pressure, low temperature liquid, and comes out as a low pressure, low temperature vapor. All right? So as it comes out as a low temperature, remember, we don't want liquid going into the compressor. That's why we got to make sure that we have nothing but vapor going into the compressor. All right? So, matter of fact, this is probably one of the reasons why they put a little dip right there to kind of catch the liquid if by some reason gets by it and gets into there, to prevent it from coming back into here. All right? As the vapor comes in, goes to the compressor. The compressor takes the low pressure, low temperature vapor and compresses the gas, which excites it. And once it gets excited, it gets extremely hot and it goes from, let's say this is about 55 to 60 degrees, and it comes out 210 degrees Fahrenheit. So it goes in about 60 to 55 to 60 degrees Fahrenheit, and then it comes out 210 degrees Fahrenheit. It's because when it compresses the gas, it excites it and creates an extreme amount of heat. That's why the name of it is called a compressor. It's basically a pump. Basically, it's just a pump, a motor that pumps refrigerant. But its purpose is they take low pressure, low temperature vapor and increase the temperature to a high pressure, high temperature vapor. All right. And the purpose of that is to condition the refrigerant so we can eject it outside. And I'll cover that a little more later. All right. So the compressor increases the pressure of the refrigerant to increase the temperature. So when pressure goes up, temperature goes up. And that's what the purpose of the compressor is to take the low pressure vapor and turn it into high pressure vapor, which increases the temperature. All right. Just like the meter device, remember, it reduces pressure to reduce the temperature. This increases the pressure to increase the temperature of the refrigerant. All right. So now it's a high pressure, high temperature vapor coming in through here and going into the condenser. All right. And this is the condenser. It's going into the condenser. All right. It's going in as a vapor. As it goes through these coils, and you can't see them because these fins cover them up, but there's coils in here, but you can see the loops of the coils through here. As it goes through here and we pull outside air over this coils, it starts to cool down the high pressure, high temperature vapor. And it's like basically inside here it's starting to rain. As it cools, it becomes liquid again. And as it becomes liquid, before it comes out, it's nothing but liquid coming out of it. So now it's nothing but high pressure, high temperature liquid at this point. And again, as it goes from a liquid and goes through the meter device, the meter device reduces it from a high pressure, high temperature liquid, and turns it into a low pressure, low temperature liquid again. And then it starts the whole process over again. All right? That's the basic circuit. And the refrigerators and the window units, even the split systems, which is not covered under EPA 608 Type 1, but that's how all of them actually basically work, except you may have different types of metering devices, and you may have different types of compressors, big ones, small ones, and most of the split systems have service valves. This one doesn't, because this is what they consider a small appliance, and and even the refrigerators have this tube right here where you can access the system. All right. Remember, how does heat travel from a high to low, from a high temperature to a low temperature? High temperature wants to make the low temperature the same as the high temperature. The high temperature wants to make the low temperature the same as it. All right. So that's how heat travels. It goes from a high temperature to a low temperature. So what we do is we want to catch the fish, right? So we make this a low temperature. So when that high temperature comes across it, that high temperature attaches to the evaporator. So the evaporator now transfers the heat from the inside the house into the refrigerant. So now the refrigerant has it. And now the refrigerant has it, turns the refrigerant into a vapor. Now the heat that's in the refrigerant goes into here, and then it takes that low pressure, low temperature vapor and compresses it, makes it a high pressure, high temperature vapor, comes out. The reason why we're conditioning the refrigerant here is because what is it normally outside? All right, we got 60 degree to 55 to 60 degree Fahrenheit refrigerant, and that's the temperature of it at this point right here. And if we was to try to send it through, bypass the compressor and go through the condenser, we would absorb more heat, because normally in the summertime, heat is around 85 to 100 something degrees, right? So if we see 60, how does heat travel? From a high to a low. So the outside temperature is a high, and the inside temperature on this is a low. So we wouldn't be able to eject heat. We would be absorbing heat. And that's not what we're trying to do. We're trying to eject the heat outside. We're trying to catch it inside and take it outside. So we make this a low temperature, and we bring the high temperature across it. We catch it. Now the refrigerant has the high temperature. I'm taking it through here, but we need to make it where we can eject it. So what we do is we compress it, make it 210 degrees. So 210 degrees is higher than the outside temperature, because if the outside temperature, the ambient temperature, is ever 210 degrees, we're dead. You follow me? So they make it well above the outside temperature. So let's say on a very hot day, it's 100 degrees. That refrigerant is still 210 degrees. So how does heat travel? From a high to low. So this is a high, and where's the low? The outside temperature. So the 210 degrees is trying to go to the 100-degree temperature outside, which normally around Abilene is about 95. So it's attaching to the 95-degree temperature. So we're going from going from a low, from a high to a low on the outside, and then we're going from a high to a low on the inside on the evaporator. All right, guys. I'll have some more videos on this to help you understand the process. All right, guys. Bye.